Hello everyone, welcome to my channel. In this video, we will learn conditional processing. In Chapter 1, we learned how to create a data set by selecting variables. Conditional processing allows us to select observations when creating a data set. This topic is based on Chapter 3 in Handbook of SAS-data-set Programming Book. Many applications require the data step to process only part of the observations that meet the condition of a specified expression. In this situation, we can use the subsetting if statement. The expression in the subsetting if statement can be any valid SAS expression. If the expression is true for the observation, SAS continues to execute statements in the data step and includes the current observation in the dataset. The resulting SAS dataset contains a subset of the external file, or SAS dataset. If the expression is false, then no further statements are processed for that observation, and SAS immediately returns to the beginning of the data step. That is to say, the remaining program statements in the data step are not executed, and the current observation is not written to the output dataset. For example, program 3.5 creates a data set that only contains the observations, in which the score variable is not missing. Checking whether score is not missing is specified as an expression in the subsetting if statement. Sometimes it is more efficient, or easier, to specify a condition for excluding observations, instead of including observations in the output dataset. In this situation, we can combine the if-then statement with the delete statement. Program 3.6 provides an alternative version of Program 3.5 by using the if-then and delete statements. Sometimes we may want to create a dataset that only contains the contents from the PDV when reading the last observation from the input dataset. We can create a temporary variable by using the end equals option in the set statement as a flag to signal when the last observation is being read. The variable after the keyword end equals is a temporary variable that contains an end of file indicator. The variable is initialized to 0 at the beginning of the data step iteration and is set to 1 when the set statement reads the last observation of the input dataset. Since the variable is a temporary variable, it is not added to the output dataset. Program 3.7 calculates the total score and lists the total number of observations from the input data. In this program, the temporary variable, last, is used to indicate when to read the last observation of the input data. The output data set only contains the last processed observation because of using the subsetting if statement. Restructuring data is a common task for a SAS programmer. The purpose of the transformation to different formats is to suit the data format requirement for different types of statistical procedures. This type of data transformation can be easily done by using more advanced programming techniques, such as array processing, described in Chapter 6, or the transpose procedure, described in Chapter 10. However, this can also be accomplished without advanced techniques for simple cases. Suppose that we are transforming data from the wide format to the long format. Notice that the time variable in the long format is used to distinguish the different measurements for each subject in the wide format. The original variables in the wide format, S1 to S3, become the variable score in the long format. Since only 2 observations need to be read from the wide dataset, there will be only 2 iterations for the data step processing. That means we need to generate the output up to 3 times for each iteration. In some iterations, the output might not be generated 3 times, because missing values in variables S1 to S3 will not be outputted in the long dataset. This program illustrates the data transformation by multiple output statements in one data step. The output statements are embedded within the if-then statements. Again, let's go through the data step execution phase of this program. At the beginning of the first iteration, _n_ is initialized to 1, and the rest of the variables are set to missing. The set statement copies the first observation from the input data to the PDV. The time variable is assigned with value 1. The score variable is assigned with the value from the S1 variable, which is 3. Since the score variable is not missing, SAS copies the variables that are marked with K from the PDV to the output dataset. Notice that variables S1 to S3 are marked with D, because these 3 variables are specified in the drop equals dataset option in the data statement. After the first observation is generated, the time variable is assigned with value 2. The score variable is assigned with the value from the S2 variable. Since the score variable is not missing, the second record is generated from the output statement. The time variable is assigned with value 3. The score variable is assigned with the value from the S3 variable. Since the score variable is not missing, the third record is generated from the output statement. Since we used explicit output statements, there is no more implicit output. When SAS reaches the end of the first iteration of the data step, we've already generated 3 records in the output dataset. At the beginning of the second iteration, _n_ is incremented to 2. ID, S1 to S3 variables are retained from the previous iteration. The newly created variables, time and score, are set to missing. The set statement copies the second observation from the input data to the PDV. Time is assigned with value 1 again. Score is assigned with the value from S1. Since score is not missing, the fourth observation is generated by the output statement. Time is assigned with value 2. Score is assigned with the value from S2. Since score variable contains the missing value, no output is generated from this statement. Time is assigned with value 3, and score is assigned with the value from S3. Since score is not missing, then the fifth observation is generated. SAS reaches the end of data step of the second iteration, and returns to the beginning of data step, to start with the third iteration. Since there is no more observation to read in the third iteration, SAS goes to the next data, or proc step. Now, let's review what we've learned from this video. In this video, we learned how to process data conditionally, in the data step. Conditional processing allows us to create a dataset, by selecting observations from an input data. We can either select observations by using the subsetting if statement, or combining the if-then statement with the delete statement. We also learned how to restructure data from the wide format to the long format, by utilizing multiple if-then statements, with output statements. I hope you enjoyed this video. Please subscribe to my channel, and click the bell icon to get new video updates.